recording. So a couple questions a lot of times you'll get when you're doing systems of inequalities. They might ask you a question, for example. So for example, they might ask you if an ordered pair, if it's a solution. So for example, if they ask you for 3, 5, you would just go to 3, 5. That would be here. Since that's not in our that's here just so it's clear. That's not in our overlapping region, so that would be no. So to be a solution to a system of inequalities, it's got to be in that overlapping shading region. For example, if they ask you, would 0, 2 be a solution? See how 0, 2 would be that on the dashed line, so that would actually not be a solution as well. So if they ask you for points a solution to your systems of inequality, it either needs to be on like a solid line that contains the shaded region, or it needs to be like in the middle of the overlapping colors, if that makes sense. So we'll look at that today. Like I'll ask you some questions like, would this be a solution? Would that be a solution? Kind of thing, just to kind of practice that. But basically, to be a solution, it's got to be in that overlapping region. If it's on a dotted line, it's not a solution. If it's only in one of the colors, it's not a solution. It's got to be in that overlapping where you have both colors or both parts of your shading overlapping. All right, for B, solving a system of linear inequalities, we're just going to look at another example. So this is kind of what I was just mentioning above. The solution to a system of equations, like what we saw earlier this week, is just a point. So like when you graph two lines, it's just the point that they cross, that's your solution. But the solution of a system of inequalities is the overlap. Sorry, that's really hard to squeeze in on here, but the overlap of the two regions that make the inequality true. So let's look at another example. And same idea, like I said, I like to, like usually when you're in class, I would have you use two different colors, but I like to first just ask myself the question, is it going to be dashed or solid? That one would be dashed because it's just less than. And since it's less than, we shade below. You don't need to write this out. Like, for example, if I was having you turn someone in, I don't need you to write this out, but you definitely want to ask yourself those two questions in your head. Dashed or solid, below or above. Those are the two things you need to think about before you graph each line. For the second one, I'll do in blue. Since it's greater than or equal to, it's going to be a solid line. And since it's greater than, we're going to shade above. So you don't need to write those out like every question. I mean, obviously I'm writing them out in the notes here, but you definitely at least want to ask yourself those two questions as you go through the graphing process. So for the red one, we're going to start up at 5. And since it's a dash line, you're right. I'm glad you mentioned that, Brooklyn. We really should put an open circle because it's a dash line, like none of the points are really included. And then our slope is 2 over 1. Oh, yeah. And I mean, I guess you could put like open circles here, but usually we just put like, we just do a dash line anyways, or a dotted line. So I've seen different people do different things. Like some people are like, say you need to do that open circle, but I mean, you do solid points like, or dashes like when you're making it. So that's something I've never really cared too much about. I mean, as long as you have a dash line or a solid line, that's usually what I just look for. Just with the understanding that a dash line, it's not part of your answer. Okay, but that would be our first line. And like we said, we're going to shade below. So you can just pick any point and go straight down. So like this would be below, like everything like here. It gets a little bit messy though. So here, maybe I'm gonna do a highlighter. I think that might look a little bit better on this. Yeah, that's a better idea. Should have been. Okay, I'll try not to like overlap so it doesn't get dark like that. All right, so then we're gonna graph our second line. So our second line's solid. So we start down at -1 and our slope is -1 over 2. So we're gonna go down 1, right 2, down 1, right 2. And then if you want to go the opposite way, we'd go up 1, left 2, up 1, left 2. Let's do it one more time, up 1, left 2. So I'll try and connect this the best I can. And like we said, we want to shade above this line, so I'll try the highlighter. Yeah, I think that looks a little bit better. But you can kind of see the overlap is here. I'll like highlight it in black. I don't know. But it's like this quadrant like here, like this top right, kind of like, I don't know, it looks kind of like a trapezoid to me. So here, I'm actually going to delete like some of that blue highlighting, but so the solution is just this region here. But this was like part of our blue, but it wasn't part of our solution. So, and for example, you might, like I said, you might see questions like, would certain points be a solution? So like, for example, would 3, 4 be a solution? Well, you would just go to 3, 4. That would be in our shaded region. So yes, that would be a solution. Like it's in that kind of like the blackish dark region I made. And then, for example, would 2, -2 be a solution? You would go to the point 2, -2. Since it's on like a solid line and it's shaded in red, like it's solid and it's in that red region, that would also be a solution. So if it's kind of like on an outer edge and it's a solid line, that is also a solution. But say, for example, like we picked the point 0, 5, like that was like part of our dashed line. That would not be a solution because it's on a dashed line outside of our shaded region, if that makes sense. So, but usually you're just checking, is it in the shaded region, yes or no? But if it's on an outer edge of the shaded region, it depends if it's on a solid line or a dashed line. That's what you want to look for. If it's on a solid line, yes, it is. If it's on a dashed line on the outer edge of it, it would not be a solution. Any questions so far? And I'm sorry, it's a little bit rough, but so our first example we're going to look at is if you're just graphing, just these ones are just kind of like, you can have inequalities that are just going to be vertical or horizontal lines. So this first one, remember, this is going to be a solid because it has greater than or equal to, and since it's greater than or equal to, we're going to shade above. And we'll talk about it because it's kind of a special case for like a vertical line. And then for this one, y less than 4 is a dashed or dotted line. And since it's less than, we're going to shade below. So we'll just graph these one at a time. X greater than or equal to -3, well, you would go to -3, and it's going to be a vertical line. Remember, x equals a number is a vertical line. It's kind of backwards of the axes. So that line would, let me zoom in a little bit. So that line would look like this. I could draw a straight line. I was looking on Notability. I didn't see a way to, like, this program to see if there's like a ruler tool, but I didn't see one, which kind of sucks. I don't know if there's a way to, there probably is a way to make it do straight lines, but I don't know. I couldn't figure it out. And since this is a vertical line, there really is no above it, but so greater than a vertical line means it's getting bigger. So that would be to the right of a vertical line. So that's kind of like a special case, but this would be greater than that line there. You would shade to the right. Here, let me undo that because that looks kind of bad. So then we'll sketch our second inequality. So y less than 4. So it's going to be, and you would, I guess you could do an open circle. Oh, it's +4. And then it's going to be a horizontal line that's dashed. And we said we're going to shade below. So it would look like this. So our, and some people like to like outline it, but our solution would be like this region here. Some people like some people in class, like when we do these, some people, if they have like a little Sharpie, like a lot of times they like to outline their answer. That's something you can do. but your answer is like between those shaded region, and it'd actually be like touching that blue line on the left. I just couldn't do it. I didn't want to like go over the entire line so you can't see it anymore. But that would be our shaded region, if that makes sense. And it's no different. So like our second problem here, it's no different if you have 3 inequalities. You're just going to sketch all 3 like lines basically. But your goal is to see if you have 3 colors, that you basically have 3 colors, and then your answer would be the overlap between all 3 colors, if that makes sense. So it can get a little bit crazy. We'll see how it looks on here. But this first one I'll do in red. This is going to be a solid, and it's going to go below. Well, it's going to be hard for me to squeeze here. I'm going to use some abbreviations. So I'm just going to put S and below, solid and below. This next one we'll do in blue. So that's also going to be solid, but it's going to go above. And then this one here, once again, it is solid, but this one is less than or equal to, so it's going to go below. So we'll just sketch these one at a time. So solid, y less than or equal to 2. So that's going to be a horizontal line. And we want to go below that one. This one might look a little bit crazy with the 3 colors, but we'll see. So then the blue line, its y is greater than or equal to -3. So that's just going to be like 1 below it. And we're shading above. Okay, and then
was positive.
wait,
The
what?
first equation was positive.
Oh yeah, you're right. You're right. When you're right, you're right. Here, let's just undo that really quick. Good catch. Good catch. I was wondering. I was like, yeah, that's really close. Like I was like, did I really make a I mean, it could happen, I guess, but I was like, yeah, that did seem a little funny. Okay, let's just fix that really quick. All right, and then we're gonna shade below the first one, right? Yep. Good catch, though. Thank you. I was wondering. I was like, something doesn't seem right here. All right, and then blue. Okay, so I did have that one right. You're gonna shade above. So you can already see like the overlap. If it was just between these 2 inequalities, it would just be like kind of this middle rectangle. But then we got to do this green one really quick. So that's x less than or equal to -4. So that'd be a vertical line like this. So then we're going to shade, what is it, below. So below a vertical line would be to the left of it, because that would be like less than. So our answer would be like this little square. But remember, it would keep going forever, like off the graph. But obviously, from what we can see, it would just be that little square. But it would obviously, like if you kept drawing like add into this graph, like it would go forever. Like it would be like a giant rectangle going that direction. Okay, so that's the idea. If you have vertical or horizontal lines, we're going to just look at, maybe we'll just do 3 and 4 today, and then we'll maybe look at the rest of this tomorrow, and then I'll give you a short assignment in like probably Delta Math, or if I find something better, I'll look tonight. But so same idea. In 3, they're already solved, so we don't have to solve. We'll see in number 4, you're going to want to get them in slope intercept form. But so these ones, oops, let me make that thinner. So these ones are pretty much good to go. So this one's going to be solid. And since it's less than, you're going to go below. This one is greater than, so, but it's, so no equal to, so it's dashed, and it goes above because it's greater than. So we'll just sketch these really quick. So -3, up 1/2, just go the opposite direction. Remember, to go the opposite direction, just do the complete opposite. Instead of going up 1, right 2, go down 1, left 2. Okay, that's probably good. And that one was solid. And we said we want to go below. Oop. I don't know what I just did. I don't know what the heck that. Oh, you can like hold it over there. Okay. Oh, hit it. Go away. All right, good enough. And then our next one's going to be a dashed line at 2x. So that's really like a y-intercept of 0. So up 2 over 1. Let's go the other way a little bit. And probably good enough. The thing with systems of inequalities, like most of the time, you're just trying to get a rough sketch. It's usually not going to be 100% accurate. I mean, you want to be accurate enough so you could check some points potentially, but for the most part, it's hard to like, even when you're doing these like on paper and pencil, to be like 100% accurate. Like even with like rulers and stuff, like, I mean, unless you're really careful, it's hard to get it super, super accurate. Then above this line would be like this. So our solution would be like this little kind of triangular region. Like, so everything in here has the overlap. Let's just look at example 4, and then we'll kind of wrap it up today. And we'll finish these tomorrow. But similar idea, we need to solve these equations. Like we need to get them by themselves. And we'll see if I can do this with the space I'm given. Like, so like for this first equation, you would subtract the x over. So you'd have this. And then you're going to divide everything by 3. So our first inequality would be really like this. So I'm just going to outline that. For our second one, I'll try and do it in blue. We're going to subtract the x. I'm just going to write it over here. So we'd have negative 2y is greater than or equal to negative x plus 4. But be careful. Do you guys remember what you have to do when you divide by a negative with an inequality? So if you divide or if you multiply by a negative, you got to make sure you flip your inequality. So this greater than would flip to a less than or equal to. And then that would be, since it's a negative over a negative, that would be 1/2 x. And then that would be minus 2. So sorry, I know that's kind of hard to read. Let's see if I can just write it again. It's a little bit better. That would be our second. Just be careful if you're solving for an inequality, like getting it in the correct form. If you divide by a negative number, you're going to have to flip your inequality. So be careful about that, because obviously that would throw off your shading. You would have the wrong shaded region potentially if you did that. So that's something, just be careful. It's an easy mistake to make. So this first one I'm going to do in red, we would start up at 1. We would go down 1, right 3. And got crap in the way, but we'll just ignore it. So this one's a dashed line. That's pretty bad. Okay, it's a dashed line. And we're going to shade below. And then for our second equation, it's a solid line. We start down at 2. And our slope is positive 1/2, so up 1, right 2. Left 2. So look roughly like that. And since we flipped our inequality, it's going to go below. So that is like really important, because you should see that below would be here. So this region is our solution, like between like this kind of triangular region here. Like, so if you want to outline it, so that's usually not a bad idea to outline it. Kind of makes it pop a little bit. But like I said, these questions I'm giving you, you're going to be doing them in Delta Math, so you won't really have to worry too much about like making it look nice on your paper. But you would see if you did have the wrong, like you forgot to flip your inequality, it would have been like the overlap would have been here, which would have been wrong. So like just be careful about that. So that's the idea of solving linear inequalities. So maybe one thing we'll just kind of practice tomorrow is just testing points. But the idea is if you're checking if a point's a solution, it has to be like in your overlapped region or on the boundary. Like for example, if you had a point on like it's hard. Let me see if I can just do like a yellow highlight. Like if you had a point here on the boundary, that would be a solution. But if you had a point on this boundary, like here, since that's part of a dashed line, it would not be a solution. So you got to be careful if it's like on the boundary of your shaded region, if it's on a solid line or a dotted line. But usually most of the time, if you're testing a point, it's going to be like in the center somewhere of your overlapped region. But that's the idea of these. Let me